Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise question number 1. A family in a village produced two types of rattan chairs, namely small rattan chairs and big rattan chairs. The family is able to get at least 60 kg of rattan a week as the raw material. A small rattan chair requires 3 kg of rattan, while a big rattan chair requires 5 kg of rattans. There are 60 workers. 2 workers are required to produce 1 small rattan chair, while 3 workers are required to produce 1 big rattan chair. And there are some add-in information for this question. At least 5 small rattan chairs and at least 5 big rattan chairs are produced. A. If X number of small rattan chairs and Y numbers of big rattan chairs are produced in a week, write 4 linear inequalities that satisfy the above conditions. So, we can build the table with rattan, number of worker, and then we have small rattan chairs, X unit, and big rattan chairs, Y unit. Okay, then we put the total or the sum. Alright, so the rattan that we use for the small rattan chair is 3 kg. Okay, and the big rattan chair use 5 kg. And the sum of them, alright, must be at least 60 kg. Alright, because the family able to get at least 60 kg of the rattan. Okay. Then, number of workers, we need 2 workers to produce 1 small rattan chair and 3 workers to produce 1 big rattan chair. So the sum of workers that needed must be less than or equals to 60 because we have only 60 workers. So first constraint, we are given that at least 5 small rattan chairs. So the X must be greater and equals to 5, where the Y also must be at least greater and equals to 5. Here we have 2 constraints. And from the table, we have 3X plus 5Y greater and equals to 60 as in here. Number 4, for the number of workers, 2X plus 3Y should be less than and equals to 60. So B, using a scale of 2 cm of 5 rattan chairs on both axes, construct and label the region R that satisfy all the linear inequalities. So we can use the graph given, alright? So you will see X equals to 5 and X must be greater and equals to 5. We want the region on the right of the line. And Y equals to 5, where Y greater and equals to 5, we want the region above the line. Then next, 3X plus 5Y greater and equals to 60. So when 3X plus 5Y equals to 60, this is the line. We will get our Y-intercept when X is 0. So Y equals to 12. So you will cut 12 here. And the X-intercept when Y equals to 0 for 3X equals to 60, we'll get X equals to 20. So we get this line. And we want greater and equals to 60. So we want the region above the line. Then about the number of workers, we have 2X plus 3Y smaller and equals to 60. So when 2X plus 3Y equals to 60, get the Y-intercept where the X equals to 0, Y should be equals to 20. Okay, so we have 0, 20. And the X-intercept, when Y equals to 0, 2X equals to 60, so 1X equals to 30. So we have this straight line. And we want less than and equals. Therefore, we want the region below the straight line. So this is our region R. C. The price for a small rattan chair is 40 ringgit and the price for a big rattan chair is 80 ringgit. From the graph in B, find number 1, the values of X and Y that will provide the family with a maximum income. So, we need to form an objective function for the maximum income or for the income. Alright, so for the objective function equals to K equals to 40X plus 80Y. Then with this objective function, we let K equals to 400 and get the Y-intercept and X-intercept respectively and draw out the objective function line. Okay, then we want the maximum income. Therefore, we will push this line toward the right of the feasible region, and it should be the last point from the feasible region. So let's push it, and we'll see it stops here. When we can get from the graph, this is 5,16.67. So 17 is out of the feasible region. Therefore, the nearest integer that we can get is only 516. So the optimum point is on 516. Therefore, x equals to 5 and y equals to 16 will provide the family with a maximum income. Number 2, the maximum income. So if you want the maximum income, we need to substitute the 5 and 16 into the objective function. So maximum income equals to 40 times 5 plus 80 times 16, and we get 328 ringgit Malaysia. A baker takes 2.5 hours to bake an orange cake and 3 hours to bake a strawberry cake. The cost of making an orange cake and a strawberry cake are 15 ringgit and 20 ringgit respectively. In a week, the baker can bake X orange cakes and Y strawberry cakes based on the following conditions. Number 1, the baker works at least 30 hours a week. Number 2, the total cost of baking both cakes is not more than 300 a week. Number 3, the number of orange cakes is not more than twice the number of strawberry cakes. A. Write 3 linear inequalities other than x greater than 0, greater and equals to 0, and y greater and equals to 0 that satisfy all the constraints above. So we can build a table that's about cake. We have orange cakes and strawberry cakes, where orange represented by x and the number of strawberry cakes represented by y. Right? Then we have information about the time to bake a cake. Alright? So we need 2.5 hours to bake an orange cake and 3 hours to bake a strawberry cake. And the total time must be at least 30 hours. So must be greater and equals to 30. Then the cost, 15 ringgit for orange cake and strawberry cake for 20 ringgit. Then the cost is not more than 300, so it must be less than and equals to 300. So from these two, we can form the linear inequalities with 2.5x plus 3y greater and equals to 30. So to make it easier to plot our point in the graph later, we make all this number in integer. So we have 5x plus 6y greater and equals to 60. Each term is times 2. Second constraint, 15x plus 20y should be less than and equals to 300, which is about the cost. So to simplify this, we see 15, 20 and 300 all can divided by 5. So each of these terms divided by 5, we get 3x plus 4y less than and equals to 60. This is our second inequalities. Third inequalities, the number of orange cakes, which is x, is not more than twice the number of strawberry cakes. So the x must be less than and equals to 2y. Then B, using 2 cm scale to represent 2 cakes on both axes, construct and label the region R that satisfy all the above constraints. So from the graph, from the first linear inequality, 5x plus 6y greater and equals to 60. So 5x plus 6y equals to 60. Get the y-intercept, which is x equals to 0. The y should be equals to 10. And x-intercept, when y equals to 0, our x will be 12. So we get this line. And the linear inequalities, positive 6y is on the greater side. Therefore, we want the upper region of this line. Then second, 3x plus 4y equals to 60. So 3x plus 4y equals to 60. Get the y-intercept when x equals to 0. 60 divided by 4, we have 15. So y equals to 15 when x equals to 0. And the x-intercept when y equals to 0, x will be 20. So this is our line. And the region that we want, positive y, is on the lesser part. So we want the region below the graph. Then third linear inequality, x should be smaller and equals to 2y. So for the x equals to 2y, x-intercept and y-intercept is on the same point that pass through origin. So we will choose another point along this straight line. Okay, let's say when we choose x equals to 12, then y should be 12 divided by 2, that we get 6. So we have 12, 6. So we know that the x equals to 2y not only pass through 0, 0, the origin, it will pass through 12, 6 as well. So we get this straight line, x equals to 2y. And the positive y, the 2y, is on the greater side. Therefore, we want the region above the straight line. Therefore, this is our region R. C. Using the graph obtained in B, find the maximum profit of the baker in a week if the profit from an orange cake and a strawberry cake are 17 ringgit and 20 ringgit respectively. So first, we need to build our objective function. K equals to 17x plus 20y. And we get a value of k. So let the k be 340. Alright. So 340 will be equals to 17x plus 20y. So get the y-intercept and x-intercept and plot out the straight line. We get this long straight line. Then find the maximum profit of the baker. So when we want maximum profit, we want the last point from here, from the origin until the very last point. So when we comes outside, okay, from the right of the region, then we have to come for the first point. Alright, so we'll move our line and we see this is considered the last point from the left and the first point on the right. So therefore, this happens for our maximum profit. So the maximum profit is on 12, 6. So sub the 12 and 6 into our objective function. 17 times 12 plus 20 times 6, we have 324 ringgit Malaysia. Number 3. A post office wants to send at most 600 parcels to City M using X lorries and Y vans. The transportation for the parcel are subjected to the following constraint. Number 1. A lorry can carry 120 parcels, while a van can carry 50 parcels. Number 2. The number of van used is not more than 3 times the number of lorry used. Number 3. The number of vans used is at least 2. A. Other than x greater than or equals to 0 and y greater than or equals to 0, write 3 linear inequalities that satisfy all the constraints above. So, we can build our table with lorries in X and Y vans. So, the parcel sent by lorry is 120 parcel for 1 lorry and 50 parcel by 1 van. And the total parcel sent must be at most 600, will be less than and equals to 600. So we have 120x plus 50y should be lesser and equals to 600. So after simplify this, we have 12x plus 5y less than and equals to 60. Then second constraint, the number of van used, which is the y, is not more than, so less than and equals to 3 times of the lorry used, 3x. So we can straight away translate the sentence, become y less than and equals to 3x. So the third constraint, the number of van used is at least 2. So number of van used, the y must be at least greater and equals to 2. So this is our third constraint. So B, using a 2 cm scale to a lorry on the x-axis and 2 cm to 2 vans on the y-axis, construct and label the region R that satisfy all the above constraints. So we have different scale for the lorry and vans. For the lorry, 2 cm to a lorry and 2 cm to 2 vans. Alright, so be very careful. When we draw the graph, we get this. Okay. So for the first linear inequalities, 12x plus 5y smaller and equals to 60. To draw 12x plus 5y equals to 60, get the y-intercept, y will be equals to 12, and x-intercept, and x should be equals to 5. So we have 12 and 5 as the y-intercept and x-intercept. And then for the second constraint, y less than and equals to 3x, we need to draw y equals to 3x. So when x equals to 0, y will be equals to 0 as well, pass through 0, 0, the origin. And then the second point I will choose, let's say x equals to 4. Okay, so when x equals to 4, y is 3 times of 4, which is 12. So when x equals to 4, y should be equals to 12. So we know this straight line will pass through origin and 4, 12. So this is the straight line that we get. Third line, the number of vans used is at least 2. So the y greater than equals to 2, we want to draw a line on y equals to 2. So y greater than equals to 2, I want the region above. And then 12x plus 5y lesser and equals to 60. So I want the region below of the straight line of 12x plus 5y equals to 60. This is the part. And y less than and equals to 3x, I want the lower region of y equals to 3x. So we'll get our region R here. C. Using the graph obtained in B, find number 1, the range of the numbers of lorry if 2 vans are used. So if 2 vans are used, so when the y is 2, what is the range of number of x? Number of lorry is represented by x. So when the y is 2, we already draw the straight line. Okay, and the range of x is not started by 0.7. Look carefully because we don't have 0.7 lorries. Alright, so it should be from 1 to 4. Okay, but not 4.2. So our range of x will be from 1 to 4. So x will be greater and equals to 1 and smaller and equals to 4. Number 2, the maximum cost occurs. The maximum cost incurs if the cost of transportation by a lorry and a van is 150 ringgit and 100 ringgit respectively. So when we want the maximum cost, write the objective function for the cost. And then we need to get a value for the k and get the reference line. So let the k equals to 600, 600 equals to 100x plus 100y. Get the y-intercept and x-intercept of this objective function line. So we will get this straight line in orange. Then we want maximum. So we'll push this line toward the right. So move it. And we'll see the last point, alright, is on 2.3, okay, and 6.6. We don't have lorries in 2.2 and 6.6 vans. So therefore, the nearest integer that we can get maximum profit is, the maximum cost is 2 lorries and 6 vans. Alright, it happens at 2.6. Alright, not 2.5. Alright, so we choose 2.6. So it happened on 2.6. So the maximum cost equals to 150 times 2 plus 100 times 6, and we get 900 ringgit Malaysia. Question number 4. Satya Indah Secondary School will host a motivation camp. The participants of the camps are made up of X female pupils and Y male pupils. The fee for a female pupil is 100 ringgit and the fee for a male pupil is 120 ringgit. The number of pupils in the camp is based on the following constraint. Number 1, the maximum number of pupils attending the camp is 80. Number 2, the ratio of the number of female pupils to male pupils is at least 1 to 3. Number 3, the total fees collected is not less than 5,000. A. Write 3 linear inequalities that satisfy all the above constraints other than x greater than equals to 0 and y greater than equals to 0. So A is from the number of pupils. So the x plus y must be maximum, so less than and equals to 80. There we get our first constraint. Number 2, the ratio of number of female, which is x, to the y must be at least, so greater and equals to 1 to 3. So we change this information, the ratio, into fraction. X to y must be greater and equals to 1 to 3. So now, cross multiply, we get 3x greater and equals to y. Third constraint, the total fee collected, which is 100x plus 120y, okay, is not less than, so it must be greater and equals to 5,000. There we get our third constraint. B. Using a 2 cm scale for 10 pupils on x-axis and y-axis, construct and label the region R that satisfy all the above constraints. So first, we need to get x plus y equals to 80. So this line is easy because when y-intercept, we'll get y equals to 80 and x-intercept, x is 80. So we get 80, 80. Then y equals to 3x or 3x equals to y, we'll pass through 0, 0 and then pick an x that you like. Alright, so let's say I choose 20. Okay, so y should be equals to 3 times of 20, which is 60. So I'll get a line passes through 0, 0 and 20, 60. This is my y equals to 3x. The third line, 100x plus 120y equals to 5,000. So get the y-intercept when x equals to 0, 5,000 divided by 120, we will get 42.5. Alright. Or the x-intercept when y equals to 0, the x will be 50. Alright. So therefore, we get this straight line. Then the region R, x plus y less than and equals to 80. So for this line, we want the region below the line. And 3x greater and equals to y, our positive y is on the lesser part. Alright, lesser side. So we want the region below y equals to 3x. So we want this side. Number 3, 120y positive and is on the greater side. So we want the region above this straight line. So we have our region R here. C. Using the graph obtained in B, find number 1, the minimum number of male pupils if the ratio of the number of female to male is 1 to 3. So let's see if the female to male is 1 to 3. So basically, 3x equals to 1y. We have the straight line y equals to 3x. Correct? So draw again the line and find the minimum point that getting into our feasible region. So we'll see it happened on 1133. So the minimum y is on 1133, where the y is 33. Number 2, the maximum profit obtained if the school takes 20% of the total fees collected. So write out the objective function for the maximum profit. Alright, so you will see it depends on the fee collected, right? So we need an objective function for the fee collected. So the fee collected we have just now was 100x plus 120y equals to 5,000. And we want maximum from this line. Therefore, we'll push this line, orange line, toward the maximum point. So we will see maximum fee collected on 2060. Where the maximum fee collected is actually 100 times of 20 plus 100 times of 60. So we get 9,200 ringgit Malaysia. This is the fee collected. So to get the maximum profit, we'll get 25% of the 9,200 and we get 2,300 ringgit Malaysia. Number 5. A factory produces 2 types of cupboards, namely cupboard A and cupboard B. Each cupboard requires 2 types of raw material P and Q. The amount of each raw material needed to produce each unit of cupboard A and cupboard B are shown in the table below. So, the cupboard A and B needs number of raw material P, Q as 2, 3, 5, 2. Alright? So the amount of raw material P and Q available to the factory are 30 units and 24 units respectively, it is given that the number of cupboard A produced is at most twice the number of cupboard B, right? Suppose the factory produced X unit of cupboard A and Y units of cupboard B. Write three linear inequalities other than X greater than equals to 0 and Y greater than equals to 0 which satisfy all the constraints above. So when we see this table, that's a little bit confusing, right? Okay, but please label down your X and Y. Okay, so we are talking about X unit of cupboard A and Y units of cupboard B. So we will see the linear inequality form will be downward. So the first linear inequalities that we form, we have 2x plus 5y should be equals to less than and equals to 30. And the 3x plus 2y should be less than and equals to 24. Alright, so we'll read this table downward. Okay. Then the third constraint is given in the text. It's given that the number of cupboard A produced, which is x, is at most twice the number of cupboard B. So the x must be less than and equals to 2y. Then B, using a scale of 2 cm to 2 units on x-axis and 2 cm to 1 units on y-axis. So we have different scale for the x and y. Construct and label the region R that satisfy all the above constraints. So let's see. First, we need to draw 2x plus 5y equals to 30. So 2x plus 5y equals to 30. Get the y-intercept, which is 30 divided by 5, we have 6. And the x-intercept, when 30 divided by 2, we have 15. Right? So this is the line, and we want less than, so we want the region below this straight line. 3x plus 2y equals to 24. Get the y-intercept of 3x plus 2y equals to 24, which is y equals to 12. And the x-intercept will be 8. So we get 12 and 8. So this is our line. And we want 3x plus 2y less than and equals to 24. Therefore, we want the region below this straight line. Lastly, x less than and equals to 2y. So when x equals to 2y, they will pass through x0 and y0, which is the origin. And we pick a y value, let's say we want 3. Okay, when y is 3, then x will be 2 times of 3, which is 6. So we'll pass through 6, 3. So we get this straight line, extend it. Okay, so when x less than and equals to 2y, the positive 2y is on the greater side. So we want the region above the straight line. So B, this is our complete graph. C, based on the graph obtained in B, find number 1, the maximum number of cupboard B produced if the factory produces 4 units of cupboard A. So 4 units of cupboard A, which is x equals to 4. So when x equals to 4, the maximum y is, we go to the maximum, we cannot say it's 4.8, but it must be a round number, so the maximum number is only 4. So maximum cupboard B is only 4 units. Number 2, the maximum profit earned by the factory if the profit from 1 unit of cupboard A is 200 and 1 unit of cupboard B is 250. So we put the objective function 200x plus 250y. So we let the k as 1000. So 1000 equals to 200x plus 250y, and get the y-intercept and x-intercept. We can plot the objective function line. Then we want maximum profit, so we move it toward the right and get the highest integer point, which is, we find that this is not an integer. So slightly turn back. Okay, it's either 5,4 or 6,3. So after comparing 5,4 and 6,3, we found that 5,4 get the maximum profit. So the maximum profit is 200 times 5 plus 250 times 4, where we get 2,000 ringgit Malaysian. Thank you.